Okay, so here's where we left off. We were kind of talking about this triangular prism. So remember we were saying there's two triangles here, the bases, and so that's why I've got the 2, and then the base and height are 5 and 8. So to find area of a triangle, remember we're doing 1/2 base times height. Plus we were saying that this like bottom triangle right here, or sorry, rectangle, is 8 by 12, so that's why I've got the 8 and 12 here. So we don't really need to say times 1, just base times height is 12. And then we've got one rectangle that's 12 by 5, that's this side rectangle over here. Okay, it's got a base of 12, height of 5. And then our last one was the hard one. We had to do Pythagorean theorem, remember? Because we're talking about this, so right here. This one here, and that 12 was this part, so don't let it confuse you. So this part, so we know this is 12, great, but we don't know this part, so we had to do Pythagorean theorem and figure out that's square root 89. So it's square root 89 times 12, which is not a very nice number. And then you can type this all in a calculator at once. I hope we know the 2 and the 1/2 will like cancel each other out, so this would be 40. This is 60. 12 times 8 is what? 96? Yeah, 96. But again, all of that doesn't really matter because we just need the whole thing. So I mean, we can type in the whole thing at once. So here, let me get a calculator on the screen so you can see what I'm talking about. Right? Like I said, I hope we know the 2 and the 1/2 are just going to be 1. So we're doing 8 times 5 plus 8 times 12 plus 12 times 5 plus square root of 89 times, whoops, got an error out of that, times 12. Hit enter, should have an answer here that's as exact as we can possibly be. Okay, so if I round to the nearest 2 decimals like it says, about 309.21. Okay, and yeah, we did leave off on this one. Hopefully you found it. It was on page 3. And this will be square feet. Okay, so we're going to go on and do a few more here on page 3. On this hexagon one, I'm not going to do this hexagonal prism, but see how they've got the triangle for you? Remember, you got to find the area of that triangle, then you got to, and it's not hexagon, my bad, pentagonal prism, definitely 5 sides, not 6, I didn't look at it very closely. So find the area of that triangle, multiply by 5, we'll have the area of the hexagon, or the pentagon, pentagon. So then we'll have the pentagon down here as well, those are congruent. As far as the rectangles, notice since it's a regular pentagon, all these rectangles have a base of that 5 right there, and they all have a height of 6, so we'll have 5 rectangles that are all exactly the same. So hexagon times 2, rectangle times 5, that'll give me the answer in the end. Okay, like I said, I'm going to let you guys do that one. As far as the cylinder, though, we are going to do number 7 here. It says find the surface area of the cylinder. We've got the radius is 5, the height is given. And so again, we have to think about what the shape's actually going to look like. So if we remember what a cylinder looks like, it's like this up here, unraveled, right? We've got 2 circles and a rectangle. So remember what we said about that. We've got 2 circles. To find the area of the circle, we're going to have to know the radius. And the radius, they tell us right there, is 5. Plus, we've got one big rectangle. And we know that the rectangle has a height of 15. And so I didn't draw my rectangle very good. Probably is more the other way. But 15 on this side. The unraveled part right here, remember we said that that base is always going to be the circumference of the circle, and the circumference of the circle is 2 pi r. So in this case, 2 times 5. 2 times pi times 5. Or in other words, 10 pi. So this is going to give us the whole surface area. Again, area of the circle, pi r squared, so pi times 5 squared, plus, we said base is 2 times pi times 5, times the height, which is 15. We can leave this all in terms of pi. Okay, this is a good one. 5 squared is 25 times the 2, so over here we've got 50 pi, plus 2 times 5 is 10, plus times 15, we've got 150 pi. So if we add all that together, we're going to get 200 pi. Again, Gotta look at what these were in centimeters, so centimeters squared. Okay, if we want a decimal, we can certainly have one. If there's a reason that I need a decimal, I go over my calculator and type in 200 pi. It's about 628.32. Okay, so either one of those is fine for an answer. Okay, so again, it's just understanding I've got two circles, one rectangle. Okay, let's flip it over to the inside and do some things that are maybe a little bit more difficult. So for number 10 here, it says solve for x given the surface area S of the right prism or right cylinder, round your answer to two decimal places. So here they give me the answer, and they want me to figure out what this x value is, and this is the base of this rectangular prism right here. It's base of the rectangle. So if I think this through again, I should have actually, the top and bottom should both be rectangles that have the same area. The left and right side rectangles should have the same area, and same with the front and the back. So I've got two rectangles that are x by 6, plus I've got two rectangles that if I say the left and the right hand one here, the right hand one we can see it's 6 times 8 there, or 6 by 8. Plus I've got two more, because I do have 6 faces to this. If I'm looking at the front and the back, I'm going to write this x back here again, because that would be x as well. If I look at the back especially, it's x for base, 8 for height, so the front would be the same. So there's my 6 faces, because I've got 2, 4, 6, right? And they tell me that in the end, that should all equal 320. So I actually have the answer this time. So I've got to work backwards. So again, base times height here is still something, it's 6x. So I've got 2 times 6x, plus 2 times this one, 6 times 8 is 48, plus 2 times this one, x times 8 is 8x, equals 320. And I know I'm kind of running out of space, so I'm going to have to get some space over here, so hopefully you're writing smaller than I am. So 2 times 6x, we're going to have 12x, plus 2 times 48 is 96, plus 16x equals 320, and you can see the algebra is going to follow from here. So 12x and 16x, we're going to combine like terms, 28x plus 96 equals 320, subtract the 96, let's see, 320 minus 96, 224, divide by 28, and x must have been 8. Okay, so lots of work there to get to x must have been 8 meters. And again, hopefully you're writing smaller than I am. And if you're not, then you're just going to have to grab another piece of paper so you can do 11 and 12. But it's the same idea. So again, think about how we did something that was like 11 on the front. Okay, do the same kind of idea here, like you're going to have to do Pythagorean theorem to find this hypotenuse. Okay, the x comes into play with this rectangle right here, but you can find all the other stuff and this rectangle over here. But again, write it out as 2 triangles, 3 rectangles, we know what it equals, and go from there. Same with number 12. Okay. We're going to do 13 and 14 because there's not pictures for those, so it makes it a little trickier. 13 says surface area of a prism, so again, very similar to number 10, okay, and we're doing a rectangular prism, that's why it's similar to 10. It says with a base with a width of x units and a height of y units, the depth of the prism is z units, write the surface area in terms of x, y, and z. So to me, if I'm drawing a rectangular prism and they've got the base is this, the depth is this, I'm thinking, okay, here's my base, there's a rectangle. Width of x units, height of y units, so I mean x and y or x and y this way. I would say x and y this way, but it doesn't really matter. And that same thing back here. Okay, this is also x and y. And then I'm going to connect them, making my prism here. And that depth is z, they're saying. So it's z, a distance going back there. So So this would also be z, and so on and so forth. My x's and y's aren't in great spots anymore, but they're okay. So again, if I think about the different triangles here, or not triangles, rectangles, sorry. I've got two rectangles, the original ones I drew, the x and y, that are literally x by y. Plus I've got two rectangles that, if I look at them, kind of like the bottom here and the top, okay, they're y by z. Plus I've got two more rectangles, I kind of think of the sides here, that are x by z. Okay? X, because like this would be x right here. So I'm talking about like this one and this one. Okay. And so I couldn't quite see what I was drawing there. So I can see that a little bit more. There we go. Now you can see them. So now we should be able to do this, because base times height. So base times height, y times x, or x, y, usually put them in order, alphabetically. Here we've got y times z, plus 2 times, and then z times x. Again, we usually put those in alphabetical order, so x and z. Okay, that's all I can do. That's the surface area. So 14 is going to be similar, except for it's a triangular prism. And again, they don't give us all the information, but they give us some. They say it's a right triangular base, has one leg length that's 6 inches, the other that's 8 inches, the height of the prism is 7 inches. So again, drawing a picture is pretty imperative here. Okay, so if I'm going to draw a right triangular prism, I'm going to draw a right triangle. They tell me one of the legs is 6 inches, the other one is 8, so I'm going to call this one 6 inches, this one 8. Then I'm going to draw the exact same triangle up here, as close as I can. And they say the height of that prism, so remember the height, and we didn't actually talk about this a ton, the height is the distance between the bases. So that distance that I just drew in, those 3 lines, they're all 7 inches long. This is 7, this is 7, this is 7. It's the distance between the bases. So again, if I want to find surface area of this, I got to think about how many different things do I have? Well, I've got 2 triangles, the bases, and I've got 3 different rectangles. So 2 triangles that look like this with 6 and 8. Then I've got 1 rectangle. If I think about this bottom rectangle, it's 8 by 7. Plus I've got another rectangle. If I think about this side one, it's 7 by 6. And then I've got 1 more that I haven't talked about yet. And that one's a little tougher because I don't know this distance right now, because it's this one right here. Okay, I know this is 7, but I don't know these ones. Okay, so I know the base is 7, kind of, or maybe it's the height, whichever way I want to look at it, but like I don't know this part. This part. So again, I need to find that. I need to do Pythagorean theorem. So I need to do 6 squared. Let's see if I can squeeze it in over here. 6 squared plus 8 squared equals c squared. 6 squared is 36, 8 squared is 64, so I'm going to get 100 equals c squared, so 10 is what this is, and this is. So we've got 7 times 10. Okay, so now I can do this then. This was all surface area, so 2, 1/2, base times height. There's my 2 triangles. One of these guys, 8 times 7. One of these, 7 times 6. Base times height's what I'm doing. One of these, 7 times 10. And then again, I can type it all into a calculator, and life is easy. Again, I hope you'd see the 2 and 1/2 cancel out. You don't have to cancel those out to 1. I mean, you really can do 2 times 0.5 times 8 times 6, and you're going to find out pretty quickly it's still 48. So the 8 times 6 part. So you really can think about that ahead of time, or not, doesn't matter. But here's the whole thing then. So the whole thing should be 216. And again, those were all in inches, so 216 square inches. Okay, so I hope that's kind of helping to see them drawn and to keep going. We're going to do maybe one or two more here. That's enough to do. So remember what your homework is too, just to kind of reiterate. So you need to do pages 1 and 2. Okay, remember that pages 1 and 2 were the original kind of assignment here, right? Like page 1 here, we did some of these already. Okay, finish out page 1, finish page 2, some of those drawings. Page 3, which we've done parts of, but you need to finish. Same with page 4 here. We did 10, 13, and 14, but you still need to do 11 and 12 and 15 and 16. And then we're going to do 18 over here, because 18 is pretty tough. 17, again, is just another kind of problem, another way to look at things. I'd suggest like making an example and making another example and kind of seeing if you're not sure. 19 is talking about wrapping paper around something, so again, it's really surface area. These are all surface area type problems. And 20, 21, 22 are all talking about the same information. But 18, let's talk about this one really quick because it's a little tricky. So it says find the radius of a right cylinder with a surface area of 48 pi square feet. The height of the cylinder is 5 feet. So again, drawing a picture isn't a bad idea here. So I've got a cylinder, and again, if you haven't thought about how to draw a cylinder yet, couple circles. They kind of look more like ovals just because I'm trying to make it like three-dimensional looking, so kind of like this picture down here, but I actually drew in my top and bottom, and then you're just going to connect from there. Okay, it should connect to the outsides. It says the radius is what we're trying to find, so we don't know the radius. The radius would be like here. We don't know it, so we're just going to call it R. We know the height, though, is 5 feet. And we know the total surface area is 48 pi square feet. So again, if we think about how to find surface area of a cylinder, remember it was 2 circles plus 1 rectangle. And the circle has to do with the radius that we don't know. And then the rectangle, when I unravel that middle part, we know it has a height of 5, but we don't know the base. And remember the base, again, we've said this a couple times, this is the circumference of that circle, so it's actually 2 pi r. In the end, we know this whole thing's supposed to equal 48 pi. We know the answer again this time. So if I think about this, it's supposed to be pi r squared, and we've got 2 of those, so this is 2 pi r squared. Again, I don't know the radius though. So that's really it for the 2 circles. Here we've got 1 rectangle that looks like this. Again, we don't know the radius, so it's 2 pi r times 5, so 10 pi r equals 48 pi. Now, I'm hoping there's some things you notice that I could actually divide out here. I could divide absolutely everything by pi and get rid of pi right away. If I divide everything through by pi, makes life easier right away. So I'm already to 2r squared plus 10r equals 48. And again, I'm hoping you can see actually there's something else I can divide through by all these too. Making life a little bit better, we've got r squared plus 5r equals 24. And then I'm hoping once you get to this point, you see I've got r squared r, a number, something's up here, because usually we don't have r squared. So I'm hoping you're thinking back to your algebra skills, and you're thinking, hey, I need to get everything to one side. So I've got r squared plus 5r minus 24 equals 0, because once I've got everything to one side, and I've got r squared and r, I can factor. And once I factor that, then I can solve. So r squared, I'm going to have r and r. I want to multiply to negative 24, but add up to 5, so that's going to need a positive 8 and a negative 3. And then the zero product property says I can set each of these equal to 0. And so r is either negative 8 or positive 3, and I'm guessing you know which one makes sense because the r was standing for the radius of circle. The radius of circle probably can't be negative, and it's not really probably, it can't be negative, so this answer doesn't make sense. So the radius must be 3 feet. I can obviously go back and check and make sure that makes sense, and I will get to 48 pi, so I'll know I did things right. Okay, so one more time. Remember what you're doing the rest of class then. You are doing pages 1 through 5, all of page 1, all of page 2, all of page 3, 4, and 5. You can work with other people, like if the desks aren't back together right now, you can put them back together. If you need to look at any of the three-dimensional shapes and or their nets, hoping that they're sitting over on the table on the side of the room, and you can look at those. But your goal is to get pages 1 through 5 done, finished, so that I can see them tomorrow. Okay, if you need to watch this video again, the link is on the board and probably on Google Classroom as well, so you can definitely watch it again tonight if you need to see some more. But they should be basically repeats of the same thing. Okay, tomorrow we'll go on and talk about cones and pyramids and how you're going to find surface area of those. If you have questions, make sure you can always stop by Math Resource any period of the day. You can get a pass to go there, or you can come by and see me in the morning and I can help you finish up anything. Thanks, guys.